Before metal, before stone tools, before anything we'd call technology, humans had one invention that changed everything: fire. But how do you make fire from nothing? Today, we're breaking down how early humans created fire and the real chemistry and physics behind it. Fire isn't magic. It's a science experiment happening right in front of you. To understand how humans made fire, we first need to understand what fire actually is. Fire only exists when heat, fuel, and oxygen come together, the fire triangle. But here's the surprising part. Solids and liquids don't burn directly, not even wood. They have to turn into vapor first, and it's the vapor that burns. You can see this with a candle. The flame isn't burning the solid wax, it's burning the wax vapors rising above the wick. That's why you can light a candle just by touching a flame to the smoke. The vapor ignites before the wick even does. When wood heats up, it goes through a process called pyrolysis. The heat breaks the solid wood into volatile hydrocarbon vapors, things like methanol, acetic acid, tars, and other light organic compounds. These vapors rise off the wood, mix with oxygen, and those vapors ignite. The flame you see isn't the wood burning, it's burning gases released from the wood. The leftover solid becomes charcoal, which glows but doesn't produce a flame because it's mostly carbon and no longer releases these light vapors. Early humans used friction to create the heat needed for pyrolysis. A hand drill, a bow drill, or a fire plow all use the same principle, turning mechanical energy into heat. As the spindle grinds against the hearthboard, it shaves tiny particles of wood into a fine dust. This dust traps heat extremely well. Once the dust reaches around 400 to 500 degrees Celsius, it begins pyrolyzing and releasing flammable vapors. That's when an ember forms, a tiny glowing bundle of hot char just beginning to burn. Some woods work better for friction fire because they grind into dust easily and heat up fast. Woods, like cedar, yucca, or willow, have the right balance of softness and dryness. Moisture is the enemy of fire. Water absorbs heat, keeps temperatures low, and stops pyrolysis before it even begins. Another early method was flint and steel. When you strike steel against flint, tiny pieces of metal are shaved off and heated instantly by friction and oxidation. These sparks can reach nearly 1,000 degrees Celsius. If they land on something like dry bark, grass, or charcloth, they heat it enough to release vapors, and those vapors ignite the same way as friction fire. Once you have a glowing ember, you place it into a tinder bundle, something dry and fibrous that can heat up quickly. When you blow gently, you add more oxygen. More oxygen means faster oxidation, which raises the temperature until the vapors in the tinder finally ignite. That moment, when invisible gases suddenly burst into flame, is the birth of fire. Early humans likely discovered fire making by accident, sparks flying off stones during tool making, or smoke forming when sticks were carved or drilled. Over generations, people learned how to repeat those moments on purpose. Fire became a tool for cooking, protection, warmth, and eventually metalworking. Fire wasn't magic. It was physics and chemistry long before humans knew those words. And it all starts with one idea: solids don't burn, the gases they release do. If you enjoyed this episode of Primitive Science, subscribe to see more content like this.